Chapter 12, I mean, just to start out a little bit, Chapter 12 talks about the case where we have more than one independent variable. And actually, the idea of having a lot of independent variables is really the majority of what we do in psychology. Quite often, we have multiple variables, a depression score, a happiness score, a measure of how much you might use substances, and maybe an outcome variable of how likely is it you get a job or you get married or you assume some of those other adult rules that happen after graduation or after college or just generally in young adulthood. The name of the chapter is a little bit misleading though, because what she's actually talking about are something called factorial designs. And this is a little bit of vocabulary. We'll get into that. She comes to us from a background in social psychology, and she starts out by talking about one variable studies and why those aren't necessarily that great. And then down here, later on, talks about interactions. And I wanted to put a marker down about the issue of interactions. So here's, how much you like a food and whether it's hot or cold and what is it? Is it ice cream or pancakes? And we're going to be talking about crossover interactions that make a letter X and ordinal interactions that make sort of a greater than or less than sign. In terms of the meat of what needs to happen in this chapter, there's really only two things. There's a little bit of vocabulary, and then later on, way down here at the bottom, we talk about the language for how to think about interactions, main effect for one variable, main effect for another variable, and what the interactions might look like. So this figure 19, when we get to it, is going to be something that we'll spend a little bit of time on. So starting out from the beginning, we'll talk a little bit about one independent variable and what an experiment with two independent variables looks like and how those show interactions. And I'll repeat myself a little bit later, but you already have been introduced to the idea of interactions earlier in the course. We talked about moderator effects. That is, an association can be different depending on what level of another variable, like sex, male versus female, or ethnicity, you have. And so, one natural question is, well, what's a moderator effect and how is it different than the factorial designs we're looking here? There is no difference. The only thing that you could talk a little bit about is we can do factorial designs that are not individual differences. So I can look at people who might be high in authoritarianism, or I might look at people who have lots and lots of reasons to drink, and ask questions about whether associations on another variable vary as a function of that, like an alcohol ad. And when you're looking at factorial designs, when you're looking in journalism, they use some language to sort of say, it depends, or for these people and those people, the relationship's a little different. So as I listen to myself on YouTube, I am trying to make a mental note of myself to not say the word so all the time. As we go into looking at one variable, it's very easy to see main effects as a result of an independent variable on a dependent variable. And generally speaking, the way that we talk about these is as a bivariate association. And we can look at a variety of dependent variables, and very often these are the ways that we display the data with our error bars and our confidence intervals. Variables with two independent variables can show interactions. And as I put up down in the note, you can also just use the word moderator effect. I'm going to admit somebody. Kyle is coming in. You can look at them as moderator effects. Factorial designs can test the limits of the external validity of your study, and they can also help us with our better understanding of the construct validity. So in the case where both of your independent variables are not an individual difference, like male versus female or young versus old, you might look at individuals who are higher or lower on some psychological construct and test whether the relationship of that construct to another construct varies. Factorial designs are nice because we can use them to test theories. So they tell us whether a simple association, whether a simple correlation coefficient between two variables tells the story that we need to between two variables or not. And as I mentioned, kind of at the beginning, when we're looking at factorial results, we're mainly thinking about main effects and interactions. And the way that we can do that within this study is by looking at a 2x2 or a 3x3 table with levels of the dependent variables being looked at. So as we're looking at a language for interactions, very frequently we say there is a difference in differences. If I place men in a situation where they are exposed to alcohol ads and not exposed to alcohol ads, and ask them in each condition how much would they crave alcohol at some point, perhaps the difference between those two conditions is different than it would be if women were similarly placed in those two situations. And it's in slightly longer words, we're saying the effect of one independent variable depends on the level of the other independent variable. That is, it moderates the effect. I have a little bit of comment about these two interactions. This X crossover interaction is different than the ordinal interaction you're seeing on the right-hand side. And the reason for that is very frequently when we're looking at our dependent variable, we might be interested in transforming that dependent variable. As you're looking at studies that, move this over here, as you're looking at studies that use analysis of variance, you might read that people will say things like, oh, we had heteroscedasticity, that is, the standard deviation of the dependent variable was different in some of the cells of our design from other cells of our design. And frequently, as a way to fix that, people will transform things. You might hear people say, oh, we did a logarithm, a log transform of the data, where we took the square root of the dependent variable as a way of keeping the standard deviations kind of the same across the cells of our analysis of variance design. Well, if you have an X interaction, that is a disordinal interaction, generally speaking, you're going to still see that pattern of X coming in your data, regardless of how you transform the dependent variable. On the other hand, if you have this ordinal interaction, like the one on the right, you can make these interactions appear and go away depending on how you scale the, in this case, rated deliciousness of the sandwich. So in terms of how we think about these things, we're a little bit happier to see these crossover interactions going on than we are to see these ordinal interactions going on. When we're designing a factorial design, we look at two main effects. In this case, one variable we might be interested in looking at is Are you on your cell phone or are you not on your cell phone? So you're driving. And another variable we might be interested in looking at are younger drivers and older drivers. You know, younger drivers are a lot better at driving. They have better reaction than us old fuddy-duddies. In order to see, though, if the effect of being on a cell phone or not on a cell phone while you drive is different depending on whether you are young or old, we need to explore all four conditions. Now, in the studies that we're talking about here, you're designing the study this way. And for reasons that you just have to kind of take it on faith from me at the moment, life becomes a little bit more complicated, statistically speaking, in terms of power, if we don't have proportional numbers of the same proportions of younger and older drivers in the two cell phone conditions. So if I'm looking merely at, say, status as a first-generation college student and status as identified male or female in student population, if I go out and do a study in this MU students, I'm just going to take what numbers I get. There's going to be different numbers of first generation and non-first generation students in the male and the female categories across that. But in the studies that we're talking about here, we're controlling how many people are in each of the four conditions that we have. And here is where we get into this 2x2 design. That is, we're going to take one level of our independent variable and tabulate that, and the other level of the independent variable and tabulate that, and put the mean scores in each of these four cells. And graphically then, we can do the following little line graph. And what we're doing here, and again, you know, it's one of those things, if I don't know what you don't know, when you look at this graph, this is then going to answer the question, is there an interaction? And looking at a graph, you should also be able to tell if there are some main effects going on in the data. And in the before times, I can stand up in front and I can put my fingers out and talk about squeezing these lines together and getting the means. The bottom line of the interpretation of this particular graph is that it shows that we have a main effect for cell phone usage. That is, if I come over here and I look on the left, I've got the means of the two on the cell phone groups are a lot, in terms of breaking time, are higher than when they're not on the phone. And I also have a main effect for age. That is, if I take this line down here of the younger drivers and I squeeze those two lines together, I get a number that's lower than if I've got squeezed these two dots together for the older drivers. So, you know, it takes older drivers longer to brake than younger drivers. So this is a picture where I have two main effects. Generally speaking, in this picture, it doesn't look like there's that much of an interaction. That is, the slope of this line, the difference in braking time from being on the phone and not being on the phone, doesn't look like it's that much different than it was for the younger drivers. Okay? So, you know, I got the chat up here and I can look at it. Come and let me know, what is this making sense to you? Is this something that you have done in other classes?
So with the, so we can tell that there's two main effects because the, so like the older drivers and the younger drivers are like far apart. They're not like in the same range. And then we can see there's the main effect of being on the phone because like braking time decreases for both of them.
Yep.
And so then with interaction, there's no interaction because they're both about the same.
The slope of those lines is about the same, yeah.
Okay.
So, you know, if, for example, I mean, I really don't like doing this over the internet because when I lecture, I can, you know, I can draw pictures and I can point and stab at things. So the first thing that I do when I explain this to people is you take your fingers and you kind of squeeze, like taking the line for the older drivers, you squeeze the on the cell phone and not on the cell phone dots together, that little regression line, and that will be the mean for the older drivers. And you do the same thing for the younger drivers, and then you see if those two dots are different, and that's your evidence for a main effect for age. And similarly, if I take the young and the old drivers together, that is, they're on different lines now, on the cell phone, and I kind of squeeze and look at the mean there, and do the same thing for the not on the cell phone, younger and older, and do the mean there, that's going to show me my main effect for being on the cell phone. And the fact that the slopes of these lines look about the same tells me that it's probably not that much of an interaction. Okay. And we're going to get.
Would it be an interaction if when the lines cross?
Definitely if they cross. So if, for example, when the younger drivers are not on the phone, all of a sudden, their braking time would be really, really huge, like up around 1150. That would make an X, and that would certainly be an interaction. But to cite a more, and that would be a disordinal interaction. That is, that would be a crossover interaction. Now, let's do a more realistic scenario. Yes, I too have a daughter slightly older than you, but she definitely thinks that it doesn't hurt that much for her being on the cell phone as long as she's not talking or texting to anyone. So she uses it, for example, to use Google Maps and so forth to travel. Well, so say, for example, young people are just better with the technology than us old people, and their braking times were relatively the same. So maybe on the cell phone and not on the cell phone, maybe it's a flat line. Let's just say it's 800 in both conditions. That would also be an interaction. So the difference is different depending on whether you are young or old. If you're young, for example, maybe there's absolutely no difference. And if you're old, there's a big difference. Or maybe if they're young, there's a difference, but it's only a slight difference. Maybe instead of a 900 to whatever it is, 775 difference. Oh, I can look at the numbers over there. Instead of 912 versus 780, maybe it's 900 versus 890. Just a little bit of a difference. That can also be an interaction. Okay. And we're going to get some practice, on that little figure that I showed at the beginning, where we walk through a 2x2 design and then go, oh, here's where we have an X. Here's where we have a main effect for one variable, but no main effect for the other, etc. But the key message of this slide is we're going to make ourselves a 2x2 design. You can extend that. You could look, for example, at younger, middle-aged, and older drivers and have 3 levels just the same, but you'd have 3 lines in your graph as a result. Okay. Thank you. Anything else? So in terms of, my question, have you seen this, have you talked about this kind of stuff before in classes? Because it does kind of get talked about in substantive classes. First time, okay. That tells me to pace things appropriately then. Not much to say about this slide. Yes, as you're looking at up here in the little line graph on the top, I'm looking at 2 levels of an independent variable. Did you get a placebo or did you get an alcoholic drink? And how do you rate a shock intensity? And that's different depending on whether you are light or heavy in terms of weight. Alcohol uptake is different depending on your weight because your body can process alcohol differently. And on the bottom, she's saying, well, yes, it's the case that we can look at moderator effects. And these are words for the same thing. So we can test the theory of how strong alcohol cues are depending on levels of another variable. We can look at interactions to test a memory theory. Now, this is a study that was done, I believe, when Bruce was, excuse me, was at Duke. I have to go back and check that article. But this is a study called a cueing study. So we're going to show people a photograph of plant and a photograph of alcohol. And then we're going to pair this with aggressive and neutral words and see whether people can respond by identifying aggression-related words. This is, this is an example. I've got, again, in this case, one independent variable is the picture type I'm showing them, and my dependent variable is looking how fast people react to the word, and the other independent variable is whether the word that I'm showing them is an aggression word or whether it's a neutral word. It should be pointed out, that a lot of these implicit cueing tests in social psychology are among the least replicable. So you can kind of Google Bartholow and Hines and replication, and they will, you will see that it's been difficult to replicate this study, but we'll leave that to the side for the moment. So what we have here is a crossover interaction. We have our alcohol and our plant study. Yes, if you're looking at aggression-related words, the reaction time for the alcohol was less than for the plant photo. And similarly, if it was a neutral word, the alcohol photo was reaction time was slower in the alcohol condition than in the plant condition. So this is an example of a crossover interaction. And a second example is to look at remembering things, remembering a chess piece. And what we have here is we have children and the children are chess experts, and we have adults, and we're showing them, we're testing them, their memory on whether this is a chess piece or whether it's digit of some sort. And what we're finding here is that the children who were chess experts do significantly better in remembering chess pieces because it's something they're really, really into than adult novices. So again, you have this crossover interaction. Children chess experts recall an awful lot of chess pieces. The adult novices not so much. Child chess experts don't seem to recall the digits that much. And the adult novices seem to recall the digits a little bit better. They're not showing us the error bars here. It is probably the case, if you look at the data, that what you're finding here is that the chess piece child expert mean is significantly higher than the remaining three means. If we had the error bars in here, we could make a little bit of a better judgment of that. So, the purpose of this is just thinking about a 2x2, and here's a couple of examples for studies that might look at that. Now, this leads up to the question of how are we going to summarize the results in our study? It might be the case that the differences are evident with only one of the independent variable, and the other independent variable didn't make much of a difference at all. It might be the case that there's main effects for both of the variables, but there's no interaction. Or it might be, as she said before, that there is a difference in the differences across condition as a function of the other independent variable. Now you can work with your 2x2 design, and you can get a sense of what the main effects look like. What we're doing is we're taking, let's just talk about the Bartholow study up here in the top. We're going to take an average for the aggressive word across both the alcohol and the plant condition. So 555 is an average of 551 and 559. And similarly, we'll take an average across our two neutral values. And we can then compare if 555 is that much different than 557. So in terms of being able to see if there is a difference in reaction time for recalling a word, depending on whether it's an aggressive or neutral word, it looks like there's really not that big of a main effect for the type of word that you have. And similarly, I can look at it vertically and I can calculate an average of 551 and 562 and get 556.5 and do the same thing for plant and compare these two numbers and ask myself the question, is there a main effect for alcohol versus plant conditions? Like when you are shown an alcohol photo, is that necessarily going to affect all of your reaction times, regardless of whether you are looking at an aggressive or a neutral word? Same song, second verse for our body weight and drinking condition. So what I might be interested in looking at is when you're being given a placebo, is there a main effect for shock intensity, regardless of whether you are light or heavy? So I can take the average of 509 and 472, that gives me 491, and the average of 6 and 7.19, that gives me 6.60. And I can compare that 4.91 with the 6.6, and that will tell me if there's a main effect for being in the placebo or the drunk condition. Similarly, I can do the same thing for the men. And I said, well, I'll average across the alcohol and placebo conditions and get an average for the light men versus the heavy men. And that will tell me, do heavy men rate shock intensity systematically differently than lighter men? So when we conclude that there are main effects going on and only main effects, we're saying that any differences going on inside this little 2x2 cell are the same across condition. Okay. And this is saying in words, as I look at the difference, I can ask myself the question, is the difference between these conditions different across levels of the other phototype? And I can do that either horizontally or vertically. So in this case, if I'm looking at the effect for aggressive and neutral words in the alcohol photo condition, I've got a -11 versus a 7 for the plant condition. And a test of an interaction answers the question, is this -11 different than this 7? Similarly, I can do the same thing horizontally. If we're going to the cell phone condition, I can look at the younger drivers and say, oh, for younger drivers, it's 132, and for older drivers, it's 174. Is that difference, 132 versus 174, different across age groups? Now, it's kind of the case as you're thinking about this stuff, in my life, since I've done, 32 years, well, actually more than that if you count other years, of teaching statistics to people, there's kind of people who have algebraic minds and there's people who have kind of graphical minds. And one of the things I like about it is I can cater to both. I speak kind of sort of both. Now, some people really like working with these 2x2 cells and putting the numbers together. And other people kind of like to look at the picture. And it's okay, God built truth with many doors so that all who seek her may find her, like Khalil Gibran said. It doesn't really matter. It's just that when which you prefer, one is not more rigorous than the other. Being able to go from a little table and make yourself a little picture is an entirely fine way to do things. And if you see a picture and you're kind of wondering about it, make yourself a 2x2 table. And here's what your tables can look like. Over here on the left, we've been looking at, line graphs for looking at these interactions. So in the Bartholow study, we have our little X there, and we have our bars here. The fact that we have some overlap is okay. I mean, this is why we don't visually look at bar graphs to tell ourselves if we have an interaction going on. You would do an analysis of variance and test the interaction. Another way of looking at it is with your more traditional bar graph, and you look at one bar next to the other and say, is the difference across these in heights that different? And both of those are fine. It's a little bit of practice. The chapter does a nice job of putting this into words, so we'll let the book do its work. As you're looking at these things, you might say child chess experts remember more chess pieces than digits, but novices can remember more digits than chess pieces. This is obviously if this is a real crossover interaction and all four cells are different. Maybe it's the case as you're looking at these things, you might just say, as I said before, child chess experts remember chess pieces. It really depends on how you follow up your statistical analysis. And similarly for the question of alcohol intake, you might say, the drunk group is much more aggressive than the placebo group, especially for heavy men. In other words, the slope of this line for the heavy men is a bit different than for the other one, even though both lines go up between the placebo and the drunk group. Okay. Now, when you're talking about a study and you've got main effects, or only one main effect in an interaction, it's probably more important to tell your reader or to think about what that interaction is. Because if you think a little bit about it, if you have a crossover interaction, that really might not tell you the full story. So let me make this a little bit bigger so we can look at it. So up here, for example, if you have a beautiful crossover interaction like this, you're not going to see any main effects. That is, if I take the heavy blue line here and I squeeze these 2 points together and make a little mean across those conditions, and I take the light blue line and I squeeze those two together, those two means lay on top of each other. That is, there's no main effect for whether you are in the younger or the older driver condition in this example. And similarly, there's no main effect for the other variable, because if I squeeze together the two means for being on the cell phone versus not on the cell phone, I have a horizontal line here. There's no main effect across the other two conditions. So when I'm looking at an interaction, that the first thing out of the box that I really want to say is, this is different depending on the condition that you are in. So let's come downstairs here and take a look at one main effect only and no interaction. So in this case, if you're on the cell phone or not on your cell phone, your accident rates are going to be the same, regardless of whether you're a younger or an older driver. It's just that younger drivers in this little scenario happen to have more accidents. So that's a main effect for only the one variable. I can have a main effect, but on the other variable as well. So in this case, I've got two lines that lay right on top of each other. And if they're on the phone or not on the phone, there's a main effect. If you're on the cell phone, you're going to have more accidents. But younger drivers and older drivers tend to have about the same accidents in this scenario. And then down here, we have an ordinal interaction. That is, if you're on the cell phone, you're going to get the same amount of accidents regardless of whether you're younger or older. But if you're not on the phone and you are an older driver, you're going to have fewer. So as you interpret this, if you wanted to describe it, there is an interaction between younger and older drivers. I would have a main effect for younger versus older if I squeeze the endpoints of these two lines together, but I tend not to talk. And similarly, I would have a main effect for the other variable. These two dots lay on top of each other. If I squeeze these two dots over on the right together, I'm going to get a main effect there. But the important thing I need to talk about is that the difference in whether you are on the cell phone or not on the cell phone is really quite different depending on whether you're a younger or an older driver. So, in terms of prepping for tests, in terms of talking with people next semester in other research methods classes, the point of this chapter is to gain some facility in saying where main effects are and whether there is an interaction there, and being able to recognize what those look like in terms of looking at your 2x2 design or looking at a line picture. Now, we could walk through a few more scenarios here. Here I've got a main effect for younger versus older drivers, squeezing these two lines together. And it looks like I have a slight difference, a slight interaction, but the difference is much more dramatic for younger drivers than it is for older drivers. And in this particular case, I don't have any effects. I have no main effect for being on the cell phone or not on the cell phone. And I have no main effect for whether you are younger versus older. And there's no interaction going on. So the pattern of the marginal means for this scenario look the same as the pattern for the marginal means we started out with. It's just that in this first example, we have an interaction going on. Come here. And similarly, another interaction could be that I have no main effect for younger versus older, that if I squeeze the dark blue line together, I have a value that overlaps completely with the other one. But there's an interaction going on. Specifically, if you're a younger driver, there's no main effect at all for being on the cell phone or not on the cell phone, whereas for the older drivers, there's a big main effect. And similarly, for this last example, if I've got an interaction going on, but if you're not on the phone, the accident rate is the same regardless of whether you are young or old. But if you're on the cell phone, our younger drivers seem to be more prone to accidents than the older ones. I think that's probably flipped in reality. But visually speaking, spend your time thinking about these figure 12.19, because that's the language with which you interpret what is going on. Now, factorial designs, that is, being able to lay things out on a 2x2 table, can take, there can be some variations on those. These can be independent groups, men versus women, heavy versus light men. They can be within group studies. In the Barcelo study, for example, they're showing people in a plant condition or an alcohol condition. I can get fancy. One of the levels can be mixed and the other one can be within. That is, I could look at the same older adults on the phone and not on the phone, and the same younger adults on the phone and not on the phone. And as I mentioned before, you don't necessarily have to have just 2x2s. You could have 3 or 4 or 5 levels. And you don't necessarily have to be stuck with only 2 of them. You could say, I'm going to look at lighter and heavier men and women in an alcohol and placebo condition. That is, I can have a 2x2x2 design and not just a 2-way design. And she then spells out, what those things are in terms of what they actually look like. If I'm looking at 4 cells, I have a between subjects factorial design. If I got different people in each of the boxes in my design. If I'm looking at within groups, I'm going to have the same people, exposed. So I might, if I'm thinking in this middle one about the Bartholomew study, maybe it's the same person exposed to neutral and aggression words and to the alcohol and plant photo conditions. Over here on the left-hand side, there are different people, as you can tell by the numbers. So you have 48 different people here. A completely within groups design is only 12 people. Maybe over here I can do a mixed design. That is, I can have 12 people over here in the alcohol photo condition who are exposed to neutral and aggression words, and another 12 people over here in the plant condition. And your choice of whether you're going to do an independent groups design or a within groups design or a mixed design depends first on power, and secondly on whether people are going to be reactive to the condition. So what do I mean by that? Well, in the middle example, where it's a within groups design and I've got the same people, I have more statistical power because I'm looking at reaction times. Maybe some of my people are just systematically quicker with reaction time than other people. Well, a within groups design is going to be more powerful because I can adjust for, it's like everyone's matched across all of the conditions. In the case of independent groups, I have maybe the need to get more people because there's a lot of variation going on between people across conditions. Now, if, for example, showing people an alcohol photo somehow contaminates how they answer in the plant photo condition, I can't necessarily have the same people. So in those cases, I would employ a mixed design. So this is a little bit of a vocabulary thing. Independent groups design, within groups, and mixed design. So know what those words mean. A completely within groups design is the easiest one. That's why I started with it. We have the same people across all the conditions. The next easiest one is an independence groups design. Every cell is different people. And a mixed design is when I repeat levels of some of my variables, but not others. And she talks about that as well. We're almost to the end of this, and we'll put a pin in it when we're at time. I can do more than 2 levels, as I mentioned. That is, I might have a hands-free cell or a handheld cell phone and look at the levels. This speaks again to the external validity of the study. Maybe it expands some of the real-world conditions people actually work with. Similarly, I might expand the levels of age in looking at things. When I was at Penn State and doing a postdoc, one of my roommates, as a matter of fact, was really into vision. And there is a substantial reason to believe that for people who are older than 70, how they process their environment is a lot different than youngsters like me who are only 65. In terms of ability to pick things out in the environment and respond. So you might want to extend what you're looking at in terms of age groups in order to have a better sense of what's going on. Sometimes that's driven by theoretical conditions. Sometimes that's driven by policy conditions. So wait a minute. And you can also increase the number of your variables. So in this case, we're looking at a 2 by 2 by 2 design. That is, I'm doing my original younger and older drivers on the cell phone and not, but I'm under conditions of light traffic and heavy traffic. And when that happens, you basically have to sit down and draw yourself out 2 different pictures. And an interaction in those situations says that there is a difference in differences depending on the third variable. And what we see here in this little scenario is that in light traffic, if you are an older driver, there's an effect for being on the hands-free cell phone, but not for the younger drivers. However, if you're in heavy traffic, there's a main effect for both the younger and the older drivers, and there's also an age effect for younger versus older drivers. Well, I see I'm at time here. I don't have very many slides left in this presentation, but we'll finish this off and then we'll come back and go into the next chapter after that.